Hello friends and welcome. In this video we are going to learn how to solve the linear equations by the matrices method. And first, to solve linear equation by the matrices method, we have to convert it first into matrices, and by converting it into matrices we will get three matrices. Any of the name of matrices could be A, B, C, D, anything, but the matrices that contains the variable should name X. So after converting the matrices into variables, we are going to have three matrices, two matrices on the right side of the equality and a single matrix on the left side of the equality. So we have to find the value of the variables. In the previous video, we have learned to find the value of the variables when they come into a matrices. That is the different method. But for linear equation, a different method or different approach is going to be used. So we have to find the value of variables. So that include in this matrix, we have to just remove this matrix from here. So you all know, when you multiply a matrix with its inverse, then it gives us the identity matrix. And for equation, whenever you apply a single operation to the one side of an equation, you have to apply it to the other side. So here you have to take the inverse of the matrix to make it identity, and the same inverse is going to multiply it on the other side. In this way, here it become identity, and on the other hand you have to multiply the inverse with the other matrix. And for solution of the variables, you have to take the inverse of the matrix and then multiply it with the other matrix. That is the method. I know there must be confusion regarding the method, but we are going to solve it with example and you will get a clear concept how to solve the linear equations. Friends, here I have taken two equations. One is x minus y equals to 2 and the second one is 2x plus y equals to 3. Here first we have to create a matrix that only contains the coefficients of the variable. So let's create a matrix. Here friends, where there is no number, that means it is 1. In case of x we have 1. In case of here y we have 1. But here is a sign minus, so we will take it along with the sign. So the coefficient of this equation become 1 minus 1, and then we have to write the coefficient of the other equation. Here 2x, the coefficient is 2, and plus y, the coefficient is 1. So in this way we have created a matrix that contains the coefficient of the equation, and with these coefficients we have to write the variables that are x and y. So we have created a matrix that contains the coefficient of the variables in the equations, and then we have created a matrix that contains the variable, and on the other side these two numbers are going to be written in a matrix form. So in this way, the first thing of the how to solve linear equation, we have to convert our equations into the matrices. What method is used? We have to first write the coefficients of the variables into the matrix along with their signs. Then we have created a matrix that only contains the variable, and the right hand side the elements are written in a matrix. So in this way we have three matrices. We can name we can name them. So let's just take, suppose this matrix is A, this matrix is going to be X, and this matrix is B. As I have explained earlier that how to find the values and how to solve this, we have to remove this matrix by multiplying it with its inverse, and we are going to apply the same thing on the other side. So how to find the matrix that contains the variables? We have to take the inverse of a first matrix and then multiply it with the second matrix. So for solution, we know we have to take the inverse of the first matrix and then multiply it with second matrix. So let's move toward the solution of this. Here for inverse, as we have discussed earlier, how to find the inverse of a matrix. For the inverse of a matrix, we have the formula 1 over determinant of a matrix, that is whatever the name of a matrix, multiplied by the adjoint of the matrix. So by this method we are going to find the inverse, and then we have to multiply the inverse with the other matrix. So let's start first with the determinant. For the determinant of a matrix, first we have to write the element of a matrix into the bars, and then we are going to apply the formula, the multiplication of this diagonal, that is 1 into 1, and then subtracting with the other diagonal, minus 1 multiplied by 2. So it becomes 1 into 1, 1, minus 2. So it becomes 1 plus 2, which is equals to 3. So we have calculated the determinant of our matrix, that is 3. And here friends, it is 3. That means it is a non-singular matrix, so its inverse is possible. We have to first check the condition for the inverse. So here it is non-singular, that means the inverse exists. Now we are going to find the adjoint, and I have told you for adjoint what method is used. We have to interchange the position of these numbers and the signs of these numbers. Here is 1, so it will remain the same as by changing this position, and then we have to change the sign, so 1 become positive and 2 become negative. So in this way we have calculated the adjoint of the regarding matrix. Now we are putting these two values into the inverse formula. So inverse become A inverse, it becomes 1, and putting the value of determinant, that is 3, into the adjoint matrix, that is 1, 1, minus 2 and 1. So A inverse becomes, now in this case I have told you that you have to divide every single element of the adjoint matrix with the determinant. So it becomes 1 by 3 and 1 by 3 minus 2 by 3 and 1 by 3. So here friends, first we have calculated the inverse matrix, and then we are going to multiply this inverse matrix with the other matrix. So I don't have a space over here, so I'm just raising the board and doing the rest of the calculation. So friend, as we have calculated the inverse of the A matrix, that is 1 by 3, 1 by 3, 2 minus 2 by 3 and 1 by 3. And for finding the values, we have to multiply it with these other matrix. So we are going to apply the multiplication over here. For finding the x value, we have A inverse 1 by 3, 1 by 3, minus 2 by 3 and then 1 by 3. And the mean matrix is friends 2, 3. So we are going to apply multiplication over here, and the multiplication procedure, 1 by 3 multiplied by 2 plus 1 by 3, and here we are having minus 2 by 3 multiplied by 2 plus 1 by 3 multiplied by 3. So let's calculate. We have here 2 multiplied by 1, it's 2 by 3 plus 3 by 3, and here we have 2 2 are 4, minus 4 by 3 plus 1 by 3. So in next step we are going to add them. Here friends, the denominator is same, so we have to add just the numerator. 2 plus 3 becomes 5. So here it is 5 by 3, and on the other hand, that is minus 4 plus 1, that is minus 3 by 3. Minus 1 by 3. So here we have find the X matrix. So friends, we have calculated the result. So here friends, we have find the matrix the solution of the matrix X, that is going to be 5 by 3 and minus 1 by 3. So this X matrix is composed of X and Y. So we are going to replace it with its matrix, and we have in a solution numbers 5 by 3 and minus 1 by 3. This means the X have value of 5 by 3 and Y have a value of minus 1 by 3. So X equals to 5 by 3 and Y equals to minus 1 by 3. So in this way we have calculated the value of variables. It is same. We have calculated the value of variables but we have given the equations. I also told you how to find the values of variables in a matrix, but this was the linear equation method. We have to convert it into matrices and then have to solve it. It is the same procedure that we have learned earlier, and at the end when we have calculated the result, the same numbers or same positions of the numbers on the other matrix are going to be the values of variables. Hope this video is informative for you. And friends, we are going to start now 3 cross 3 matrix. The determinant of 3 cross 3 matrix, that is a complex method. So first we are going to learn about some factors regarding 3 cross 3 matrix determinant. Then we are going to learn the determinant method. Hope this video is informative, and don't forget to share, subscribe, like to my channel. And till then, take good care of yourselves and stay blessed.